So this is a question that the ladder AB is leaning against a wall at an angle alpha. Okay. Now, next what we did, we pulled from point B to a distance E. Okay, if we pull it from here, so naturally this ladder that is at point A will slide down to point D. So the horizontal distance that is moved is D and the vertical slide is H. Okay, so we'll assume this DC as X and this BC as Y. Now the question says we have to prove that D over H is cos alpha minus cos beta over sin beta minus sin alpha. Okay, now let's prove. So AB is the length of the ladder. So length of the ladder is always constant because ladder is same. So the length of AB and the length of DE, it always remains same, which is equals to L. Now in order to prove this, we'll consider two triangles. In triangle ABC, okay, let's consider this triangle ABC. Now here we will apply two things. At sin alpha will be X plus H over Y, right? No, sorry, over L, because my L is hypotenuse, that is AB. Now cross multiply this, what will get? Sin alpha is equals X plus H. Now see, we have to figure out one more ratio, that is cos alpha. So cos alpha will be adjacent. So adjacent is BC and BC is Y over a hypotenuse, that is L. So B over L. Cross multiplies, what will get? L is equals to cos alpha, that is Y. So now in triangle ABC we derive two ratios, sin alpha and cos alpha. And the reason is that because to prove we need cos alpha and cos beta, sin alpha and sin beta. So we need both these two quantities, that's why. Okay, now moving ahead. Now take another triangle, the triangle EDC. So in triangle EDC, we'll take the same two ratios, sin beta and cos beta. Now what is my sin beta? Sin beta will be opposite, which is X, adjacent is L. So cross multiply, so what will get? L times sin beta is equals to X. Now figure out cos beta is adjacent. What is the adjacent? Adjacent is Y over D over L, right? L is the hypotenuse. So now cross multiply, so what will get? L cos beta is equals to Y plus D. Okay, now see, we derived sin alpha cos alpha, sin beta cos beta from this, and we have to prove D over H is equals to this. So now what we have to do, we have to write equation in terms of D and H. Okay. Now look here, this X plus H is this, so shift H on the left hand side. Okay, so now L sin alpha minus X is equals to H, right? Now what is okay, it will be L sin alpha minus, now what is your X? See, your X here is this, L sin beta. So plug in here, L times sin beta is equals to H. Okay, we are almost done. Now shift this Y on the left hand side, so it will be L times cos beta minus Y is equals to D. Now what is your Y? Y is here, L cos alpha. So plug it in here, cos beta minus L into cos alpha, that is your D. Now see, we know what is our D, we know what is our H. So now we have H and D both, and what you have to find out is the ratio of D and H, right? So we're almost done. Now divide this D and H together. When you divide D over H, so what is D? D is L cos beta minus L cos alpha divided by, now what is your H? Where H is L sin alpha minus L cos sin beta. Now d over h will be, now see L is common in all of them, so common out L. Inside will be cos beta minus cos alpha divided by L times sin alpha minus sin beta. L and L will cancel out, so you'll have d over h is equals to, now see it is cos, but in the here it is, we have to prove cos alpha minus cos beta or sin beta minus sin alpha, so you have the opposite thing. So what you can do, common out -1, so what will be inside, it will be cos alpha minus cos beta divided by, now common out negative from bottom also, so it will be sin beta minus sin alpha. Now this negative will cancel out, so what you will get, d over h is equals to cos alpha minus cos beta minus sin beta minus sin alpha. So this is what you have to prove, and it's proved. Okay then.